All right, so again, we're back practicing solving by substitution. Remember, we're solving systems with two or more equations. Remember, when we say solving system, that means to find the point that works for both. We used to solve, or we have solved by graphing, but graphing, remember, is a little bit slower and it doesn't always give us the answer that we are sure about, so we're trying substitution now. Substitution. Remember the steps. Let's rewrite the steps for substitution. So the first step is to isolate. Isolate x or y. There shouldn't be a comma there. Step 2, we want to substitute. Substitute to the other equation. And then step 3, we want to solve. Okay, so again, those steps, we want to isolate x or y, whichever is easier, substitute to the other equation, and then solve. Isolate, substitute, solve. Isolate, substitute, solve. Okay. So let's take a look at a few easy ones first, and then we'll try a few harder ones, and then you can try the rest. So we'll just do a couple on each side, a little bit less than the day before. All right, so first step, isolate. Do I have any variables that are completely by themselves? This guy, no, he's got the 2y. This guy, no, but oh, look at this y, he's by himself. He is already isolated. We can skip this step. Skip this step, we have y equals negative 2x minus 6. They are twins. No one can tell the difference between them. So now I'm going to substitute for y right here in the other equation. So negative 2x minus, here I am, 2. Now I'm going to put a parentheses here. Instead of writing a y, think about who can show up to class instead of a y. Who is y equal to? Well, y is equal to negative 2x plus 6. Oops, kind of wrote that a little bit too small. Negative 2x plus 6. And now we just solve. Now we just solve. So let me draw my little barrier here. So we got to do a little bit of work. We're going to distribute. We have negative 2x. Let's see, a negative times a negative. Negative times a negative is a positive. Positive 4x. And negative 2 times positive 6. Negative times a positive, that's a negative. 2 times 6 is 12. All right, so now we've got, we can combine like terms. Combine like terms, 4x minus 2x. 4x minus 2x is 2x, it's a positive. 2x minus 12 equals negative 12. All right, how do we get x by itself? I got this 2 here, I got this negative 12. Let's get rid of the negative 12 first. How do I get rid of a negative 12? I need to do the opposite. What's the opposite of negative 12? Positive 12. Interesting. So that's going to give me a 0 pair. So we get 2x equals, now interestingly enough, we also have a 0 pair over here. So 2x equals 0. Never fear, we can still do that. Divide both sides by 2. And we get x equals 0 divided by 2. I start with nothing. I divide it into 2. I still have nothing. Right? So x is just 0. So to find y, I will go ahead and plug in to either equation, either the bottom here or the top one here. The top one looks easier, so I'm going to plug in this top one right here. Y equals negative 2x plus 6. Negative 2x plus 6, but we think x is 0. So we're going to get y equals 0 plus 6. And so y equals 6. So our solution, oops, is going to be the point where they cross 0, 6. 0, 6. This is my answer. Let's just check that again. Make sure that works. So plug in 0 for x, plug in 6 for y. So what would happen here? Negative 2 times 0, well, that's just 0. Does 6 equal 6? Yep. How about plug in here? 0 for x. Right, this whole thing would go away. Plug in 6 right there. Negative 2 times 6. Negative 2 times 6 is negative 12. Yep, that works there. So it works for both. So 0, 6 is the solution where they work. All right. I guess they're all for y. Okay. Number 3. Let's try number 3. So again, step 1, we want to isolate. Is there anybody isolated where x or y is just by themselves? And no, yes, this guy right here again happens to be in the same place. Y equals 3x plus 12. They are twins. They are twins. So we got our twins. Now remember, we're going to substitute into the other equation. So right where I see y here, I'm not going to write y. I'm going to write y's twin. So 4x minus 5y, right? 5y. But instead of writing y, who is y's twin? It's this guy, 3x plus 12. 3x plus 12 equals negative 5. Equals negative 5. All right, now I just solve the rest. Let's distribute. Boom, boom. Let's see, we get 4x, negative 5 times a positive 3, and negative times a positive, negative times a positive, negative 5 times 3, 15x. Ooh, 5 times 12, good thing we've been practicing. 5 times 12, let's see, I could break that down. 5 times 10 is 50, 5 times 2 is 10, 50 plus 10 is 60, but it's a negative, so it's a negative 60. Ooh, big number. And negative 5 over here. All right, let's see what we get over here. Combine like terms. That looks like different signs. Subtract. 15 minus 4. 15 minus 4 is 11. Take the sign of the bigger number, negative 11x. 60 to negative 5. All right, so we're going to add. We're going to get rid of this negative 60. What's the opposite of negative 60? It's a positive 60. So what do we get here? We're going to get a 0 pair. Negative 11x equals 60 and 5. That looks like different signs. Subtract. 60 minus 5 is 55. Take the sign of the bigger number, positive 55. Okay. Almost done here. Get the x by itself. Divide by negative 11. Divide by negative 11. This becomes a 1. Negative over negative is a positive. X equals 55 over 11. How many times 11 go into 55? 11 times what is 55? That is 5. But don't forget there's a negative here, so x is negative 5. Negative 5. All right, we've got x. We can plug into either the top or the bottom for y, but the top one looks much easier. So let's go ahead and plug it in right here. So y equals 3 times x, but we think x is negative 5. So negative 5 plus 12. 3 times negative 5. Y equals negative 15 plus 12. So y equals negative 15 plus 12. That's different sign. Subtract. 15 minus 12. 15 minus 12 is 3. Take the sign of the bigger number, negative 3. So our solution, where do these 2 points cross? It would be negative 5, comma, negative 3. Negative 5, comma, negative 3. All right, so we're on the back here. Again, we'll try a little bit more challenging problems. Solve by substitution. Remember, our first step is to isolate. Isolate x or y. Then step 2, we want to substitute to the other equation. Substitute to the other equation. And then step 3, solve. So isolate, substitute, solve. Isolate, come on now. Isolate, substitute to the other equation, and solve. All right, so isolate. He is not isolated. He is not isolated. He is not isolated, and he is not isolated. But one of these is easiest. That is the guy without any coefficients in front of them. No, 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 yes. So let's isolate y. Let's isolate y. That would be the easiest. Let's rewrite this. Negative x plus y equals negative 3. All right, how do I get this guy? Let me just draw my barrier here. You don't have to, but how do I get y by himself or herself? Well, this x is hanging out there. How do I get rid of this negative x? How do I move that over here? Well, what's the opposite of negative x? Positive x, right? Positive x. Actually, I don't need that equal sign yet. That's going to be a 0 pair. So we're going to get y equals, these are not like terms, so I just get x, right? There's the x, minus 3. Perfect. So I have isolated y. I've done my job for step 1. I have the twins. Y equals x minus 3. Those are my twins. They're exactly equal. So now I can go ahead and do my second step. Substitute to the other equation, right? I just used this equation right here. So now we're going to plug into the other equation. Since we solved for y, we're going to plug in for y right here. So let's go ahead and rewrite this equation starting with negative 2x. Negative 2x plus 3y. 3y. But instead of writing y, I'm going to substitute. Who does y equal? X minus 3. They're twins. Instead of writing a y, we're writing x minus 3. And that equals negative 8. All right, so draw our barrier here. Do some work. Distribute here, distribute here. What are we going to get? Negative 2x, 3 times x, that's 3x. And 3 times negative 3 is a negative 9. All right, so we're going to go ahead and, let's see, combine like terms. So 3x minus 2x. 3x minus 2x is 1x. Equals negative 8. All right, so how do we get x by itself? We're going to add 9 to both sides. And we get, that's a 0 pair. So x equals 9 plus negative 8. 9 minus 8 is 1. So x equals 1. So I could take this 1, I could plug it in anywhere. I could plug it in here, I could plug it in here, but I think it's easiest just to plug it in right there. So let's plug it in right there. So y equals, instead of x, I'm going to write a 1 minus 3. What is 1 minus 3? 1 minus 3 is negative 2. So our solution is 1 comma negative 2. 1 comma negative 2. All right, let's just try one more here. So number 9. Remember, step 1, you want to isolate. Let's look for isolating here. You could pick, let's see, not by himself, no, not by himself, not by herself, not by herself. None of these guys is isolated. But what we can do is look for somebody who has no coefficients. So he's bad, she's bad. But either one of these guys, either one is okay. Because look, neither one has a number in front. So you could isolate x or y. You'll get the right answer. I'll just pick x just for fun. But you could do y. See if you get the same answer. Let's isolate x. So x plus y equals 4. I want to get x by itself. By itself. Oh my goodness. Thank you. So how do I get x by itself? Well, who's hanging out with x right now? This y. How do I get rid of the y? I'm going to subtract it from both sides. That's going to give me y minus y. That's a 0. So I get x equals. Now these are not like terms. So again, I just get negative y. And that's a plus 4. X equals negative y plus 4. And there are my twins. X, negative y plus 4. So anywhere I see an x, I could write a negative y plus 4, and nobody's going to know the difference because they're the same. All right, so we just used this equation right here. So we're going to substitute into the other equation. So anywhere I see an x, oh, there it is, anywhere I see an x, I'm going to write his twin, negative y plus 4 instead. So let's go ahead and write this second equation. 3x, but instead of writing x, I'm going to write negative y plus 4. Right, instead of x, I'm going to write negative y plus 4 3x minus 4y equals negative 2. All right, let me draw my barrier. Let's solve this guy. So we'll distribute. 3 times negative y, that's a negative 3y. 3 times 4, that's a positive 12. Minus 4y equals negative 2. All right, let's combine like terms. Combine like terms. That looks like same sign, keep, and add. So that's a negative 7y. And plus 12 equals negative 2. All right, how do I get rid of this 12? What's the opposite of 12? Well, that's a negative 12. Negative 12 on both sides. That's going to be a zero pair. So we get negative 7y equals negative 2 minus 12. That appears to be same sign, keep, and add. So that's going to be negative 14. Keep and add. All right, last couple steps here. Just move this up. So that's going to be dividing by negative 7, dividing by negative 7. We're going to get y equals, right, this becomes a 1. 14 divided by 7 is 2. Negative divided by negative is a positive, so y is a positive 2. Y is positive 2. To finish it off, I can take this y, I could plug it in anywhere. I could plug it in here, here, or here. We've always been choosing this one, so why don't we pick this one, because this one's also pretty simple. So x plus y, we think y is a 2. X plus 2 equals 4. How do I get x by itself? Very simply, subtract 2 on both sides. You can draw your barrier if you want. X equals 4 minus 2, which is 2. So our solution, what is the one that works for both? 2, 2. 2, 2 is our solution. 2, 2. And if you want to see y, let's just go up here real quick and check. 2, 2. Does that really work? We'll plug in a 2 here. 2 plus 2. 2 plus 2. Does that give me 4? Yep. And 3 times 2. 3 times 2 is 6. And then 4 times 2. 4 times 2 is 8. 6 minus 8. 6 minus 8. Does that give me negative 2? Yep, it does. So 2, 2 is indeed our solution. So as you guys get going on your own on these ones, remember when there is none of them isolated, when you have to actually do some work to isolate either x or y, you want to look for, a lot of times, there's one variable that doesn't really need much work. So for number 8, we're not going to do it all together. But we can see here that none of these guys is by themselves. No one's by themselves on the side of the equal sign. But one of them, this guy right here, has no coefficient. That's going to make things easier to isolate because you won't have to divide at the end. So number 8, we're going to isolate x. Right, we're going to isolate x. That's our step 1. So take this equation, and you want to write it like this. All right, and you want to get x. You want to get x isolated by itself. So you want to get this guy out of there. Oops, don't need that. So you can just think about how can I get this negative 2y out of there over there. Just do the opposite. So do the opposite of a negative 2y. That would be, of course, positive 2y. So you will get x equals, that's a positive 2y plus 3. Remember, they're not like terms. You can't combine these. And then once you've got that, you've got your twins. X equals 2y plus 3. Right? X equals 2y plus 3. looking at number 10, which one of these guys do you think we're going to isolate? X or Y? First equation, second equation. So hopefully you see that none of these are isolated, but we can do it again with this guy X. So you do the same thing. Actually, it's pretty much the same thing, except you have a 2 here instead of a 3. So I'll let you guys tackle number 10. Number 12, you can see, again, no one is by themselves. No one is isolated yet. We have to work here. Who is the best candidate? Who has no coefficient? Who's the simplest to isolate of those 4? And hopefully you see here it is this guy, Y. So you'd want to isolate, for number 12, you want to isolate Y. So write this out, 3x plus y equals -3. Okay, so you want to get this guy by himself. You want to get y by himself. You want to get rid of a 3x. Well, how do you get rid of a 3x? What do you do to both sides? You do the opposite of 3x. That is a -3x. So you want to do -3x on both sides. And this becomes 0. And you get y equals -3x minus 3. Y equals -3x minus 3, and those are your 2 twins that you can plug into the other equation. Don't forget to plug it into the other equation. All right, try your best.